John Belkowitz from Intelligent Concrete. And time out before we get into the meat of this awesomeness today. I want you to hit that little ding on the bottom so you're getting constant feeding information. Subscribe to our channel. We post daily. Hey, listen, the biggest thing is throw me your questions. I've been getting some great questions. We answered one of them today. We're doing some colloidal silica stuff to answer more questions that we've been getting to our website. I'm here to help you out, so let me know what your questions are or concerns. All right, so we're doing the handheld penetrometer today. No, we're not. We are ripping and stripping some samples. We did these up last week, and normally I would rip them and strip them sooner, but it's a nice little unveiling. I got some 28 days, we might do those. But this was that blast absorbing concrete. It had a unit weight of somewhere around 75 pounds per cubic foot. So a little bit heavier. So what I'm doing right now is stripping them out of the mold. And again, this is a nice little unveiling for you. These are at 7 days, and the purpose of these again was for blast absorbing. So let's see. It smells real nice too. Yeah, so that's a nice looking mix right there. You don't see the aggregate pulling too much to the surface. There's a nice paste content. No really big honeycombing, no cracking yet. And normally what we see with this stuff, if you don't set up the cement paste the right way, you'll start seeing these little micro cracks. And I don't know if that's from alkali silica reactivity, I don't know if that's from volume change, but it normally happens within the first few weeks if the mix isn't set up the right way with these soda lime borosilicate beads. Alright, so you're going to see a video of some blast loading that I did, and to say something's a blast absorbing concrete, what we used to do is weight drop tests. Didn't have a lot of money, was living with mom and dad. And what I did is a heavy weight from their rafters dropped onto the concrete, and then I used a camera with a scale, and this is just a really crappy representation of it, but something with known heights and changing colors, so I could map the rebound energy from that heavy weight on a concrete panel, and that's what I was dropping it on. But if you're gonna make a blast absorbing concrete, you actually have to do blast loading. So what I did is I worked with a few of the folks in the industry who specialize in blast loading. I started at University of Denver, and what you're going to see right now, ding, is a clip. But what you see is this steel plate has a piece of concrete, 1 foot by 1 foot by 2 inch thick piece of concrete plate that's taped to the bottom side of it with gaffing tape. They call it 100-mile-an-hour tape. It's kind of like Gorilla Tape, just really awesome Gorilla Tape. And then on top of that, we had a post that was welded, and we created a scale that matched the 6-inch height scale, alternating, that matched to a scale that was standing right next to it. And the idea was to create a certain blast load, a planar load that hit the concrete from the underside and pushed it up a certain height. And if we used the same amount of C4 for each of the different blasts, without the concrete, with the blast absorbing concrete and different grades of the blast absorbing concrete, with a certain repetitiveness or number of tests, we could identify the energy absorbed by the concrete, because instead of the planar wave pushing up, you can actually see this change in the atmosphere where this wave of energy is like beating up water molecules, and it's changing the magnification of the area behind it. So again, that flat wave, the energy would be absorbed, or the energy would compress that concrete and not go through and push that steel plate up to that highest point. And the way we calculated energy was using the mass of the entire system times the velocity squared. I believe that was the equation. We used this known energy equation, and then the change in height from the X naught to the X final and the time that it took to get there to calculate the velocity throughout the entire system. Yeah, so that's what you're looking at right now. That was the video, and now we're gonna go just break it in the compression machine. I mean, what we want to know is, can this be used for a structural facility or structural material for a facility? Can this be used in foundations or more so walls and roofs, not only to protect from blast loads, but also just to be used as a structure too? That's an equally important part. So let's go find out. So we went ahead and tested our mix and got somewhere around 6,100 PSI at 7 days. It's a lot stronger than it needs to be. So if we wanted to, we would go back and we would put some larger spheres in there to give us more of that absorption of energy that would sacrifice our strength, but at 7 days with 6,100 PSI, I mean, that's going to be skyrocketed flight at 28 days, and that's just not necessary for what we're trying to do. So yeah, hope you enjoyed it. If you have any questions, any concrete concerns, don't forget to throw them in the section below. Check out our new podcast. We actually got an interview with one of the coolest cats in the industry, co-founder to a major company that's bringing a new and emerging software and hardware technology to the concrete construction industry. Check it out. We'll put a link below. Go concrete! Beat asphalt!